All right, ladies and gentlemen, so today we're now going to start getting into the algebra part where we're going to be working on solving an equation. And solving means that we get the variable alone on one side of the equal sign. That's called solving. That's our goal. How do we do it? We cancel the numbers using opposite operations, right? We talked about operations in our previous chapter, so we're going to be using inverse operations, the inverse property. Please add that in. All right, now, excuse me, our golden rule. Because this is an equal sign, it's like a balance. And just when you weigh something in science class or you go to the doctor or you step on a scale, and you have to change it because it all has to be balanced. So our golden rule for algebra is what you do to one side you must do to the other. Our first few lessons are going to be problems that I know you can do in your head. That's not what we're learning right now. What we're learning right now is how to show your work. How do you show the inverse operation so that you can show what you're doing in the problem? So when I look at number 1, it says x plus 8 equals 12. So I'm trying, my goal is to get that x by itself. To do that, I have to cancel adding 8. Well, how do I do that? I do the inverse property. The inverse of adding 8 is subtracting 8. So the way that I show that is right underneath it. I'm going to show that I'm subtracting 8. The golden rule tells me if I do it on this side of the problem, I also have to do it on the other side of the equal sign. So I have to show it under the 12. Then I draw a line, because now what I'm doing is I'm going to put these two parts of the problem together. So I haven't done anything with my x. I'm going to bring it down. 8 and negative 8, or 8 minus 8, cancel out. They make 0. That was our point, because then I can add 0 to anything, and it doesn't change it. Equals, now over here I'm going to do the math. 12 minus 8 is 4. So this is the work to show how you know that 4 plus 8 equals 12. Again, I know you could have done that in your head. That's not what this is about. This is about learning how to show your work. My way. This is one of the times that it has to be my way. All right, so for number 2, here's my variable. I want to get that by itself. To do that, I have to get rid of the subtracting 5. Well, I need the inverse. The inverse of subtracting is adding. And the golden rule says what I do to one side, I have to do to the other. Okay, so bring the x down. Now I'm going to put these things together. Subtracting 5 and adding 5 cancel each other out. Bring down the equal sign. 20 plus 5 is 25. Okay, so hopefully so far so good. So over here here's my variable. I'm subtracting 14. The opposite of that is adding 14. Golden rule says what I do to one side, I have to do to the other. I don't know why the board's acting this way. Bring down your x. Minus 14 plus 14 cancels out. 21 plus 14 is 35. So far it's looking pretty easy, right? I'm going to skip these next ones. I want to go down to where I have some, because our integer rules are not going away. All right, we'll come back to 4, 5, and 6, but our integer rules are not going away. So let's take a look at number 7. Here's my variable. I have adding 13. The inverse of that is subtracting. What I do to one side, I have to do to the other. So I bring down my x. Adding 13, subtracting 13, cancel out. So now let's take a look at this. I have negative 37 minus 13. So here's a little trick. If those two things out front look the same, you're going to just add the numbers together. And I know I just wrote over the 1, but this is 37 and 13 is going to give me 50, and it stays negative. Negative 50. So again, integer rules not going away. For number 8, I have x. There's my variable. I have to cancel the adding 91. Inverse is subtracting. So we bring down the x. 91s cancel out. So now it's 52 minus 91. So I know I'm going to get a negative. Well, over here I'm going to do my subtraction so that I can figure that out. You, by the way, could do this on a calculator. We are allowed to start using calculators now. So let's see, I have to borrow. So that's a 9, 8 minus 39. So negative 39. I want to do one with the decimal. Okay, doesn't matter. Oh, actually, I'm saying that wrong. I want to do number 11 because now I have the m on the other side of the problem. It doesn't matter what side of the problem it's on. Find your variable. You have to cancel whatever's with it. So canceling, subtracting 20, inverse is adding 20. What I do to one side, I have to do to the other. So this time now I'm going to have my number over here. So negative 12 plus 20, opposite signs means that I have to subtract the numbers. I'm going to get 8. 20 is positive, so it's a positive. Bring down my m. These 20s cancel out. So again, it doesn't matter what side of the problem your variable is on, you still want to try to get it by itself. So number 13, here's your m. I have to get rid of the 2.6. It's a positive. I know that it's a positive because there's nothing in front of it. So the opposite or inverse of a positive is a negative. So 2.6's cancel out. Bring down your m. 5.4 minus 2.6. Again, if you need to, you can put it into your calculator, but you should get 2.8 when you do that. All right, let's do another one over here with some decimals. So here's my x. I have to get rid of the minus 6.7. So inverse of that is to add it. Cancels out. Bring down your x. I have opposite signs, which means I have to subtract the numbers. So I'm going to borrow. And there's more negatives, so negative 8.7. All right, what I want you to do is to pause it, try the ones we haven't done, and then stop it to see, then play it again to see how you did. Okay, so let's see how you did. I'm going to scroll back up here. So I did the ones that we didn't do together in blue. So for number 4, you should have gotten x equals 70, 5x equals 8, 6x equals 39. 9 is m equals 39. Notice 6 and 9 were the exact same problem. All I did was change the variable, but the process is the same. For number 10, 33 equals a, 12, negative 11 equals a, and 15, 38 equals j. Notice in some of the problems I did not actually physically cross off the number you were canceling. If you like to do that, it's okay. If you don't want to do that, it's okay as well. So 11 and 12 are equally correct in their work. 11 I canceled out, 12 I did not. Or showed the actual crossing off, I should say. Again, it's about showing the work. Do not tell me that you can do it in your head. Do not tell me that you used a calculator. All of those things are fine, but this is how the problem needs to look in order to get credit. All right, any questions? Bring them to class. If not, have a nice night.